the other questions I'm going to ask you are a little bit more general, and this is going to be a lot more just from what you're seeing on the graph. So describe the trend of data for the purchasing power. So, again, this is the one that's a little less precise, but just kind of in your own words, what can you tell me about what you see in the purchasing power? What conclusions can you make based on the shape of the graph or the numbers you're seeing in the table? So that's going to be the little plus sign guys. Okay? So what's going on over time with the purchasing power? So it had that peak up at, what, 1970 we said, right? So as soon as we got just past 1970 into 1975, then we started to see a decrease. Okay? And it had a little bump up in, what was that, 2000? Okay, and then it started to come back down again. Okay, so it's had, kind of in general though, it was, the purchasing power was increasing until around 1970, and then it's been on a decline since then. Okay, say something to that effect. Okay, something like that. Doesn't have to be anything complex. Just, can you give me a basic description of what you see? Okay, then the other thing we're going to do with this stuff is we're going to go to the third type of modeling, and that's the algebra. So can we actually create equations for this stuff? Okay, for the minimum wage, for the purchasing power. So we're going to let the calculators do that for us as well. You guys did a little bit of this in Algebra 2 with lines of best fit. Okay, so what we have to do, though, is we have to decide, is it going to be a line or is it going to be something different? Because there's lots of different types of equations we could have our calculator produce for us. So if we look at the sets of data here, we've got minimum wage, we've got purchasing power. Just based on the shape of it, what kind of an equation do you think the minimum wage would fit into? What kind of a shape does it have? Yeah, there's an ever so slight curve, so maybe something with a curve to it, but a line wouldn't be bad though, right? It's pretty consistent in the way that it's going up. So we're going to do a linear equation for the minimum wage. What about the purchasing power though? What does that kind of sort of look like? Looks like it might be some kind of a trig thing. It's kind of coming back a little bit. That's true. It has this big bump up and then this little bump over there. Okay. Now, because this other little bump at the end is so much smaller than the first one, though, let's just kind of ignore that. And let's just say, what if it's just a big upside-down curve like that? What does that look like? Parabola. Okay. The other reason that I'm doing it is because a trig function with this is going to be really complex. So I don't want to do that. But so we're going to do a linear for the minimum wage, and we'll do a parabola. We'll do a quadratic for the purchasing power. Okay? So the way that we do that, go back into stat. And we're not going to edit this time. We're going to calculate something. So we're going to go over to calc. All right. And then underneath here, once you get past these first three, these all say there's lin reg, quad reg, cubic reg. And you can keep going down the list, and there's a whole bunch of them. Okay? So these are what we call regressions. It's the fancy word for it. But basically, a regression is another word for of best fit. So it's a line of best fit is number 4. A quadratic of best fit is number 5. A cubic function of best fit is number 6. And on and on and on. Okay? So we want to do a linear regression for L1 and L2, right? If you don't give it anything else after this, it automatically assumes L1 and L2. Okay? But if you wanted, because we're going to need it later, you can do L1 comma, find the comma is just above the 7, and then L2. So it'd be second 1, comma, second 2. If you type it in like that, it'll give you the same thing as if you didn't put the little L's in there, but we'll use them for the next one, so it's good to practice anyway. You don't have a comma? Some of the newer calculators operate a little differently, but in general, that's how it should look. Okay, good. Then your X list and your Y list, L1, L2. That's how you want to do it. Yeah, the newer ones, it pops up a little menu. Yeah, and it says X list, Y list. Then you're going to go L1, L2 for those two. Yeah, if that's the way it looks. In any event, when you hit enter, should get something like this. Numbers on yours should look like mine. And notice how it gives you the equation up here, but then it gives you values for A and B. So if I was going to actually write down an equation for the minimum wage, steal those numbers. Now you can round them off. Okay, you don't have to go crazy with it. But just steal those numbers and write out the equations. So for the minimum wage, it would be Y equals 0.09. I'll take it out 4 decimal places. That's usually pretty safe, but I wouldn't go any further than that. And then minus 4.8818. Okay, and for that one, Y represents years after 1900, because remember we used 55 for 1955, and we used 60 for 1960, and all of that. So that's years after 1900, and then X would be, oh, I'm sorry, this is X. That's X. And then Y would be the minimum wage. Okay, so we've got an equation for it now that we stole from our calculator. Because it appeared to be a line, so if it continues that trend, actually it's a line that's going down, right? That should not have been, that's weird. It actually gave it a positive slope even though, oh, no, that makes sense. It's minimum wage. I'm sorry, I'm thinking myself into the next one. Okay, so we said that we know the minimum wage today, right, is $8.15. So we could check that out, see if it fits the pattern. Okay, how could we do that? If 2014 gives us $8.15, yeah. Right. 2014 is 114 years after 1900. So if we plug in a 114, is it getting close to $8.15 or not? We can check that out. Okay. So we did Y equals 0.0968 times 114 minus 4.8818. So did anybody try that already? It's 615. Okay. So what does that tell you about the minimum wage today? Right. We're seeing a greater increase in the minimum wage recently than what was historically happening. Yeah.
Another reason for the big difference could be that the top list could be running off of federal minimum wage, and then the bottom is state.
Oh, what is the federal? Is it like it's still 7 something, I think. Something like that. Okay. So even if we did do federal, then if it's 725 or whatever it is, still not as drastic, but still definitely the increase in the minimum wage is more so now than it was. Okay. So maybe if we were to look at the data over a longer period of time, if we had more data, it would look more of a curve as opposed to a line, something like that. Okay. About an equation for the purchasing power, because we said that was looking like it was kind of quadratic, right? So if we go back into stat, go over to K, which one am I going to want this time? It had kind of a parabola shape to it. Quadrag, right? So we're going to go down to number 5. Now, before you hit enter on this one, though, what two lists were we using for the purchasing power? L1 and L3. Okay, so if you got an old school calculator like mine, you got to go down and grab L1, comma L3 for the quadrag. Otherwise, just make sure where it says X list, it's L1, and where it says Y list, it's L3. Okay, and then hit enter on that, and we got this big long thing. Okay, so it's a quadratic equation, though, right? AX squared plus BX plus C. And we've got A, B, and C. We've got the numbers to plug in for those. And again, don't go nuts with it. Just decimal places off of each one. 3 or 4 is usually sufficient, and you should have something we can work with. Yeah? Yeah, don't worry about the R. That's a correlation coefficient. We'll talk about that at a later date. But so if we're going to write down this equation for purchasing power, give yourself a little bit of room. So I've got y equals negative 0. I'm going to go 3 decimal places for each one on this one. 0.002 x squared plus 0.32, if I round it, 3x minus 6.143. So if we follow that one, we could check to see what is the purchasing power today as well, right? Doing the same kind of a thing. If 114 in for X for 2014, what is our purchasing power today? If it's following that same pattern, okay? So if we do that, again, I got to be super tiny here with this. All right, did anybody crunch that out yet? Or shall I? Did we get an answer?
I'm not sure if it's right. I have 2.06.
Okay. That seems reasonable based on the trend we were seeing. Okay. So, what did we notice about the trend of the purchasing power? What was it doing? It was dropping, right? 1970 was living the good life, and then after that, we're not getting so much for our dollars anymore. So today, about $2.06 compared to what was happening in 1996. That seems to make sense from the data. Now, there's going to come a point, though, where this model doesn't make sense anymore, because eventually it's going to do what? It's going to hit 0 and then start going negative, right? And so then a different model is probably going to be better than a quadratic. But for what we had, the window we were looking at, the quadratic seemed to make the most sense. So just some things to kind of think about with that. So that's all stuff we're going to do, okay, with the modeling and that sort of thing. In part of the assignment, you're going to be comparing models from graphs to tables to equations and that sort of thing, and using your calculator to help sift through that. Want to switch gears